Orbiters around another planet are turning their instruments toward an object that originated outside the solar system. China's Tianwen-1 and NASA's Mars Reconnaissance Orbiter, as well as ESA's Mars Express and ExoMars Trace Gas Orbiter, have all shifted their focus to following this dim traveler as it approaches Mars within 30 million kilometers. We'll look at the science, the discovery, and what this interstellar visitor has in store for us in this video. Let's get started. 3. The Chilean ALIAS Survey Telescope discovered I-Atlas for the first time on July 1, 2025. Until its orbit revealed a crucial detail, it initially appeared to be uninteresting, a tiny, slow-moving speck. It was not subject to the sun's gravitational pull. That meant it was interstellar, traveling through our solar system on a one-time trajectory. This makes 3-8 only the third confirmed interstellar object after Oumuamua 2017 and Boris 2019. Unlike those earlier visitors, however, 32 Atlas was discovered early enough to organize an extensive observation campaign. Its path brought it unusually close to Mars, making it possible for orbiters there to take part. On October 3, 2025, the comet passed just 30 million kilometers from the red planet, close enough for sensitive cameras and spectrometers to detect its gas and dust emissions. NASA's Mars Reconnaissance Orbiter, MRO, is using its HiRISE camera, a half-meter telescope capable of observing fine detail on Mars to capture faint images of the comet's coma and tail. HiRISE may be able to detect brightness variations and tail ripples caused by interactions with the solar magnetic field. Despite the fact that the nucleus is too far away for direct resolution, the European Space Agency, ESA, redirected its Mars Express and ExoMars Trace Gas Orbiter, TGO, toward the event. The spectra of sunlight reflected and absorbed by the gases of the comet can be analyzed by their instruments, which include the high-resolution stereo camera and CASs. Colin Wilson, ESA's project scientist, explained that while full detail isn't expected, these measurements could still reveal the chemical makeup of the coma and its overall activity pattern. China's Tianwen-1 orbiter joined the observation effort, adding another viewpoint from a different orbital angle. All of the active orbiters gathered on Mars for a few days to study an object that formed around another star before it disappeared once more into deep space. Every interstellar object offers a direct sample of another planetary system, matter-shaped in a completely different environment, likely billions of years ago. 3i gives scientists a rare chance to compare alien chemistry with that of local comets. Observations from the James Webb Space Telescope JWST have already revealed a striking difference. 8. In contrast to the majority of comets in our solar system that primarily emit water vapor, has an estimated CO2 to water ratio of 81. This suggests that it formed in a much colder part of its home system with abundant and stable CO2 ice, similar to the outer Kuiper belt but centered on a younger or dimmer star. The comet's dust also behaves differently. Polarimetric observations indicate an unusually strong negative polarization, meaning the dust particles scatter light in a way rarely seen among solar system comets. This could indicate that compact, radiation-hardened grains have traversed interstellar space for millions of years. 3's environment near Mars adds another layer to the story. Charged particles appear to be twisting and interacting with the comet's ion tail as it passes through a disturbed region of the sun's magnetic field. It would be the first direct observation of solar magnetic influence on interstellar material if Mars orbiters detect waves or distortions in the tail. These findings are contributing to the development of a picture that is more in-depth of how planetary systems release icy bodies and how those bodies change as they move between stars. Compared with Oumuamua, which behaved unpredictably and showed no visible tail, or Borisov, which resembled a typical comet, 3i sits between both cases, active but chemically unusual. Scientists are cautious but optimistic. Each new interstellar object broadens our sense of how different planetary systems can be, and how connected they are through shared cosmic debris. The Mars flyby is only one phase of a longer campaign, After October 3rd, 3 honors will continue inward toward its perihelion, the closest point to the Sun around October 29th to 30th, 2025. As it nears the Sun, its activity is expected to rise dramatically, releasing more gas and dust and possibly reshaping its coma and tail. It will be impossible to observe it from Earth once it moves behind the Sun, but ESA's Juke spacecraft on its way to Jupiter will step in. Between November 2nd and 25th, JUICE will monitor the comet from deep space, capturing how sunlight and temperature affect its composition over time. This will be the first coordinated examination of an interstellar comet by a deep space probe and multiple planets, a multi-point network that is tracking a single object from various angles and distances, is created by these combined observations from the Mars Reconnaissance Orbiter, Mars Express, JUIC, and JWST, as well as several ground-based telescopes. This approach allows scientists to cross-verify data on its brightness, spectral emissions, and tail morphology as it reacts to solar radiation. The main scientific objective is to measure isotopic ratios in its gases, particularly carbon and oxygen. These ratios, which are like fingerprints, indicate whether 3At formed around a cooler dwarf or a sun-like star. The kind of excellent nursery that produced it could be identified by even the smallest variations. Beyond its chemistry, 33 Atlas is influencing how space agencies plan for the future. Its discovery and rapid observation campaign show the need for quick response missions that can intercept the next interstellar object before it escapes again. Several concepts, including NASA's proposed Comet Interceptor and ESA's similar studies, are being refined using lessons learned from this event. Still, scientists remain realistic about the limits. The comet is hard to see clearly, moves quickly, and is faint. Many results will rely on indirect measurements, changes in brightness, gas spectra, or tail orientation rather than resolved imagery. Even so, these fragments of data will help refine models of interstellar chemistry and the evolution of small bodies moving between stars. 3I's brief visit reminds researchers that cosmic discoveries often come without warning, and that adapting quickly may be the key to studying them before they're gone forever. The first time an interstellar comet has been studied from another planet is during the 3I Atlas flybys. Mars became our window to another star system for a brief time. Its passing reminds us that even across galaxies we are connected. Heat,